So I'll just stick that on. So just letting everyone know that I'll be recording this. And yes, thank you for everybody for muting, except I think Nancy. So maybe as long as Nancy sits quietly, probably doesn't need to mute, but it just helps with keeping things sort of quiet. There is also the opportunity to raise your hand, I think. If you work along the bottom of the screen, you can see the different options that you've got where you can mute or start your video chat. I encourage you to use the chat. Catherine, yes, could manage the chat for us. And then she can have a look and see what we're saying while I'm trying to keep control of you all. Yes, and raising our hands perhaps won't work so well because we don't have our videos on, so I won't be able to see that. Thanks, Jane, for letting me know. I was wondering where that had gone. But yes, Catherine said she'll monitor the chat for me, so we'll be able to keep on top of that. So we've got the program. I've got a bit of a program which we'll try and stick to. And we'll have a break at about 2:20 so that we can all get up and get a cup of tea and stretch our legs and rest our ears and eyes. And then we'll come back and reconvene for the second half of the program. So I guess if anyone has got any other questions before we start, what's 2:20 WA time? I'll let you do the math on that, Belinda. So it's 3 hours before 2:20. So there you go, 11:20. Thanks, Michael. Good job. And yeah, so I'll let you know anyway when we'll do that. And so yeah, I should say good morning to those in the afternoon to New South Wales, South Australia and Victorian participants. It's a bit of a challenge working across 4 time zones, but we've managed to get you all here, so that's fantastic. Yeah, sorry, I was just looking at you. We don't have the option to raise our hand, but please pop questions in the chat. So I'll hand over to Michael, who is going to give us a bit of an introduction to the soil CRC. So thanks, Michael, if you're there.
I am here, Felicity, so hopefully everybody can
hear
okay. I've been having some slow internet at this end as well.
Okay.
So great to be involved. As the CEO of the Soil CRC, let me just say a few words about myself, and then about the CRC, and then about this project. Some of this, some of you will already know, but let me start with introducing myself. Michael Crawford. I've got a background in agricultural science and soil science in particular. I worked in Victoria for many years for the Victorian Department of Agriculture, its various names. It's now Department of Jobs, Precincts and Regions. Different places in Victoria. Last 15 or so years I was in Bendigo. In the 90s I went to Adelaide and did a PhD looking at soil carbon before, dare I say, before it became the topic of the day. Yeah, there's a few of us researching soil carbon then, and had a great experience in what was then the CRC for Soil and Land Management, one of the early CRCs. Came back to Victoria, worked in the department. I started in this job just over 2.5 years ago. Moved to Newcastle, New South Wales. A big change, but it's been fantastic. And essentially, yeah, as the first CEO of the new CRC, had the job of commencing, bringing this CRC together and getting it going. I might just take Richard's suggestion, put my video on. That's who I am. See if that works without affecting the bandwidth at the moment. I'm sitting at home. We are working from home, as many of you are now, so making the best that we can. Yeah, today we would have been in Adelaide. It would have been fantastic to be in Adelaide and actually meeting you face to face. And that is unfortunately something we haven't been able to do because of coronavirus. Catherine just commenting upon my haircut. I did get my haircut done this morning in anticipation of perhaps not being able to go back to the barbers again for another few months. I thought I'd get a well and truly short haircut today. Let me talk about the Soil CRC. The CRC program has been funded by the Australian government since the early 1990s. There's been a whole range of CRCs in a whole range of different areas, including agriculture, environment, manufacturing, transport, defence, health and medicine, IT, etc., etc. So this CRC, the Soil CRC, or full name, the CRC for High Performance Soils, is number 216 in the list of CRCs. So we've got plenty of CRCs that have gone before us to learn from, but at the same time, every CRC is different in a very different and special way. A feature of this CRC, especially in the context of research and industry coming together, is the involvement of end users, of farmers, of farmer groups, grower groups in our CRC, essentially representing industry. Our industry is agriculture. It's not the soils industry per se. It's agriculture. It's farmers, big and small. And our objective, broadly speaking, is to enable farmers to be able to improve their productivity and profitability through improved soil management, and to undertake the R&D that supports that, and to undertake the outreach that enables that to happen. So our objective is not to produce high performance soils. Our objective is actually to help farmers improve their productivity and profitability, improve their business outputs, and consequently contribute to the economic outcomes of the country. In doing so, of course, we need to be also very mindful of the triple bottom line of environmental and social impacts and potential benefits of our work. So a lot of our R&D is also directed towards looking for those win-win solutions that enable us to achieve those economic and social outcomes, environmental and social outcomes, as well as the economic outcomes. I won't go over all the detail of the CRC given the context of this video chat, recognising that many of you have had some direct exposure to it already. You've had some briefing to it from Felicity through the previous workshops and some of the presenters you've had there, and you've had some exposure to it both through the and us advertising the program in expressions for interest and through the website, etc. Of the 30 participants in this program from across Australia, 11 of you are directly associated with or work for organisations that are participants in the CRC. So you have other means and ways of being engaged in the CRC. For the other 19 of you, welcome to the community. In achieving what we do in Australia, a lot of our work is directed for our participants, for our partners, but ultimately we're looking to make it available broadly, widely, achieve outcomes, achieve impact, lead to adoption through all the various pathways, which does include many of you, each of you, in your own roles and with your responsibilities in your own geographies and across Australia. This project was initiated through discussions that we had with the Commonwealth Australian Government's Department of Agriculture at the time, the Department of Agriculture, Water and Environment. And they recognised a broader need across Australia for engagement and support for those who are in turn working with farmers around the technical aspects of soil health, soil management, soil productivity, etc. So we talked about a program which we could run drawing upon the combined and collaborative expertise that we have accessible for our partners in the soil CRC, both the research partners and the grower group partners. And I think the rest of it, is history. We did get the funding, we got the project supported. We appointed the project leader for Felicity. We called for expressions of interest. We had lots of interest across Australia, 84 expressions of interest in different ways. We selected the 30 that we've got based on a range of criteria. So congratulations to you all. We hope and anticipate that at the end of this project, we can go back to the Commonwealth and demonstrate the success of this project, point to the unsated demand that was the first time around, the other 50, and look for funding to run another tranche of this, as well as to support those who've gone through the first project, such as yourselves. I'll probably call it to an end there and pass it back to Felicity. If anybody wants to ask me a question, you can probably do so via the chat. I'll stay on board for a little bit longer to answer any questions that you may have.
Thanks, Michael. Feel free to unmute yourself if you'd like to ask a question. No, that's okay. Well, we'll keep moving, and yeah, like Michael said, if you would like to use the chat to ask a question, then please do. So thanks very much for that introduction. So now we'll move to our program leaders and an introduction for the first, for program 1, which is investing in high performance soils and group framework, and the group framework introduction as well. I'll introduce Associate Professor Catherine Allen from Charles Sturt University. Catherine's going to give us a bit of a rundown on program 1. So Catherine, if you would like to share your screen with your presentation, go ahead.
Yes, just trying to do that.
Great.
Goodness knows which one of my screens you're going to see, but if it works, seamless. So thank you very much for the opportunity to talk with you today. My background, before I became an academic at Charles Sturt University and before I became program leader in the soil CRC, I was an extension officer, so particularly in soils and vegetation, and perhaps one fun fact about me was I was the second female soil extension officer in South Australia in 1986. So that tells you how old I am as well. Sorry, I'm just trying to find the right way to
That's right. So what'll happen is you go to the bottom centre.
Can you see that now?
Yeah, there you go. Yep. You've got it. Good job.
There we go.
Excellent.
I can talk and work my way through things at the same time. Excellent. Thanks, Rich. So I don't want to take up a lot of your time today, but I would like to follow on from Michael and saying this is an interesting soil CRC in that it's not about soil science, it's about agriculture, and it's about including end users and so on. My program, program 1, I shouldn't call it my program, the program that I'm honoured to lead is about the human stuff. It's I think it's called investing in high performance soils, but really that means the human stuff. The collaborators in program 1 have expertise in economics, soil science, extension practice, farming systems, innovation, entrepreneurship, farming, there you go, big data and programming. So that's why it's the human stuff, I suppose. I'm not sure if you're seeing this in any size at all on your screen, but I hope you are, because it's quite a busy little project. At the start of the Soil CRC, we ran some scoping projects where we got all the experts together, those experts that I was talking about on the last screen, the economists, the social scientists, the entrepreneur people, and we tried to work out what it is that we're dealing with change, you know, encouraging change, or if you like, adoption of new practices around soil. And none of this will be a surprise to you. There were, at one end, there's the uncertainty and the complexity and the life objectives of the people involved. And right at the other end is the adoption and action. What I'm assuming, and I hope this is correct, is that most of you, particularly in this, in your communities of practice, are working in this supporting knowledge, learning, helping people make decisions about soil. That's your focus of activity, is around that knowledge and information. I'll keep going on the assumption that that's correct. In the Soil CRC, and you'll hear from them soon, programs 2, 3 and 4, which are providing a lot of soil related research information. I've just put that as a little tiny one at the top because you can see where my focus is, all the other stuff. We have 4 types of program, 4 project areas within the Soil CRC. One of the, within program 1 of the Soil CRC. One of them is around the values that people bring to their decision making and their understanding, and in particular economic values, how that's shown in economics. We have another area of research happening around what you might call the social norms, the social acceptability, the social license, a little bit about personality cognition, a little bit about some of that psychology around, you know, why people do what they do. We have another area working around risk, which is clearly tied in with the others, but taking risk beyond just return on investment. And a 4th area looking at soil as part of the whole farming enterprise and the whole person enterprise, and looking at how people can take a bit of entrepreneurship, I suppose, and take control of their futures. You can't see what I've got there, but 1 is economics, 2 is adoptability, 3 is risk, and 4 is entrepreneurship. So I'll go into those in a little bit of detail. In the first area, the economics reflecting the value of soil stewardship, we have 3 current projects, which you can see out there. All of them led through Charles Sturt University in this particular area, around activating consumer demand, you know, seeing if there's ways of helping consumers pay more for good soil stewardship, something like a tick or whatever on produce. There's another project around ways that financial markets might reward good soil stewardship, and that's so the first one's Mark Morrison, the second one is led by Nick Pawsey, and the third one is around how land prices might better reflect good soil stewardship. Again, that's Mark Morrison. In the second area, we've got that more sort of social norms, social understanding areas. We've got a couple of projects running at the moment, one led by Vaughan Higgins at the University of Tasmania, which is really trying to develop a deep understanding of why people choose to uptake things, why people choose not to, in relation in particular to soil. Hannah Beth Luke at Southern Cross University is doing an Australia-wide very in-depth social benchmarking surveys with, again, a bit of a focus on soils, but something much broader than that, looking at people's intentions, their values, their attitudes, and some of their knowledge. Associated with this area, we've also got some PhD students looking at social norms, one who will be starting to look at appropriate ways of evaluating the success of soil outreach, which could be quite interesting for many of you, I think, and negotiating the complexities of farming in the 21st century. I'm assuming there's no questions because I can't see the comments bar at the moment, so I'll just keep going unless someone shouts at me. In the third area, the risk is really thinking beyond return on investment, that it's not just about how long will it take me to pay back my investment in something. It's really beginning to look at the variety of risks inherent in the farming occupation and also in the sort of catchment. And this allows some of the climate change variability to come into risk assessment. And that's led by Carla Saravanamuthu at University of Newcastle. At the moment, she's just doing some scoping study to see whether that is something which will have legs. So there's no large project around that at the moment, but she's been getting some good feedback from some of the grower groups, and that may work into something in the future. The fourth area is led by David Falapau at Charles Sturt University, and it's around building capability for soil innovation, for grower groups to innovate instead of, I shouldn't say it quite instead of, but not just being takers of the research funding which is available, but actually shaping futures and saying this is where we want to be in relation to soils and in relation to farming. So I'll finish with a so what, so what? Why is it important to have all this? We have a lot of really good soil research happening. Why do we need to have this extra human part? I think partly what we're here for is to encourage new collaborations among scientists, advisors, growers, and we're developing new ways of having those relationships, I suppose. Soils are being introduced into new areas of activity, and in particular to markets and banks and people who have influence in the world but don't necessarily think about soils that much. I think that's really important for people like yourselves. You'll be able to access new understandings of farmers and norms and knowledge and attitudes to help facilitate change and promote the uptake of new approaches. And really, I'm hoping that some farmers and grower groups will have some added empowerment to shape their futures, looking at understanding risks and looking at really building capacity to be able to act in their own interests and in the interests of soils. So you've seen me now. I'm pretty, I'm pretty straightforward. If you want to talk about any of these projects, just contact me, or go onto the Soil CRC website, find the project leaders I've mentioned, contact them directly. Or if you don't want to do that, I'm sure you can go through Felicity and she'll set up a meeting with us. So Felicity, that's probably all I have time for to say.
Okay, thanks.
Questions?
Catherine? Yeah. There isn't anything in the chat at the moment, but if people feel free to unmute themselves and ask a question. I guess from my point of view and my experience with working with landholders, it's a really, I think the last few years has been really tough times in relation to in Victoria, low rainfall and high prices for livestock. So one thing that I'm grappling with working with landholders is and getting them to value their soil and protect their soil when you're comparing it to the values of the commodities that they're selling. So they can just see land prices going up and cattle prices going up, and so even though their rainfall might be going down, in which case their pasture production might be going down, but they're still trying to run the same number of livestock that they might have in what they've called an average year, but we haven't had an average year for quite a number of years. So yeah, I guess it's more of a comment, but if you've got some insight into that as to how we can work with landholders to value, you know, that comparison between that value of protecting their soil resource rather than going for the short-term gain of high livestock prices. Yeah, if you've got any comment around that.
And I guess that's partly why the economic program, well, not partly why, it is why the economic program is looking to other ways that reward good soil stewardship. So there are some incentives other than just the price of cattle or the price of land, so that it's more nuanced than the information that farmers have to respond to can be more nuanced and better targeted to soil. So it's a long way off. It's not going to give you an answer for next year, but it is about how do we, because the markets don't care. The markets don't care if the capital base is run down. That's, you know, classic market theory. So it's a way of finding other triggers in the market that do provide farmers with a reason, a financial reason to manage their soils, rather than just always trying to expect farmers to have to carry the sort of burden of guilt, I guess. So it'll be an interesting area to watch that space in the next couple of years, I think.
Yeah, so Marnie's just said it's and I guess it's about farmers getting a return on their investment. So they've got their land and trying to you know, run their business. So yes, it's about persuading a farmer who might be worried about their bottom line. So it's being able to explain to those, or convince the landholder that the short-term gain while livestock prices are high, yeah, and then them trying to get a return on their land investment as well, and get ahead while prices are high. So yeah, that's part of the challenge, I guess. Yeah, and Jane's saying that farmers are, she thinks that they are starting to think about their soils and their worth, and I guess that's true in that the soil CRC has come into being, that we are valuing it.
And I think that's correct. Nobody, I don't think farmers want to run down their capital base, but just like everybody, we have to respond to signals, and we can't expect farmers to starve or not educate their children, or just, you know, it's not all on them. So that project, the projects that we're looking at in the economic part are really about helping set better societal triggers to not just put all the burden on individuals, but, you know, it won't take it's not going to be fixed this year or next year, and there's certainly nothing that we're looking at or saying that's blaming farmers and saying they're not understanding their soils. Often they're doing these things because they have to, and it's breaking their hearts. So we're really looking for ways to sort of reduce some of that and make the societal expectations actually pay for some of the things rather than making farmers pay for it.
Yeah, certainly. Richard's asked about Joel Salatin and whether people have heard of his approaches to soil health, which I think is about yeah, that holistic management view and using livestock in the system and maintaining green cover on soils for as long as possible. Yeah, so it's an interesting approach as well. Catherine, were you going to talk about the framework a little bit?
Do I have time?
Or... Yes.
Okay.
Yeah.
I don't have anything to share on screen on that.
Okay.
One of the activities that we were going to be doing at the conference, what you were going to be doing at the conference was as a group having a go at a group capacity survey that Michael Mitchell, a colleague of mine, and I have been developing in the land care space. So outside of the soil CRC, but I'm dragging it into here at the moment. It's about it's called a group capacity survey. It is about group capacity, not about individuals. It's based around 5 capitals: human capital, infrastructure capital, but specifically 3, or importantly, 3 of the social capitals: bonding, bridging, and the other capital that escapes me for the minute. So it's around how the group is operating. And Felicity and I thought it might be valuable to complete that survey as a group. So it would be 3 surveys that looks at your aspirations for what you want to do as a community of practice, and where you might have sufficient capacity in relation to those capitals, and where maybe there would be where you want to increase your capacity in those areas. And the idea, and Felicity can jump in here too, the idea was to do it early in the piece and do it again at the end as a little bit of a, you know, how has my capacity changed through being part of the community of practice? And also it helps. It's partly about the survey itself, but it's a really good conversation tool among groups. So it's not a person from the group fills it in. It's a real conversation starter around, well, what do we want to do as a group? I've seen your plans and they're great, but, you know, do we want to be continuing? Do we want to stay together as a group? If so, what will we need? So Felicity, we'll still plan to do that survey sometime. We've written it up, we've customised it to your communities of practice, and I guess it's just working out how and when we can do that.
Yeah, that's right. And so, yeah, it'll help the groups to identify their strengths and what they might need to support the group going forward, and how the group has perhaps changed from when we do it, well, sort of now-ish in the next few months, and comparing it to how we've progressed at the end, and what support you might need going forward at the end of this project. And also something that will perhaps give you a useful tool that you might be able to use with your own groups, landholder groups or land care groups that you might have to help them with their progression or whatever stage, group life cycle stage they might be at. So yeah, terrific. Okay, thanks very much, Catherine. I really appreciate that that introduction to the program, and yeah, I would encourage you all to get in contact with Catherine if you would like to progress any of those specific projects that she has identified. I've also come up with a bit of a list of the soil CRC projects that I think are relevant to the groups, each of the groups. And if there's anything that Catherine has raised today, any particular topic or project that you guys would like more information on, then I'm sure Catherine would be available to help to come and talk to the group again, or do another little webinar and expand on a particular topic if that's what you'd like. So just keep that in mind, and yeah, I encourage you to take your own notes and just jot down anything that sparks your interest, and we can progress it and delve a bit deeper over the next 12 months or so. So let's jump in. Otherwise, we'll move on to Richard Doyle. The Southern Communities of Practice are familiar with Richard. He's been a great support at our first workshop when we came together, and yesterday the Southern group met in a Zoom meeting online like this and had a quick catch up. So Richard is the Soil CRC Program 2 leader involved in soil performance metrics, and he's the Associate Professor at the University of Tasmania. So I'll hand it over to you, Richard. Thank you very much.
Thanks, Felicity. I hope you can all A, hear me, B, see me, and sorry, yeah, see these slides. Is that coming across clear, Felicity?
Yes, all clear.
Okay, cool. All right. Well, I'm Richard Doyle. I'm traditional soil scientist. I guess I call myself a soil geologist, if anything. I'm all for and about soil, and yeah, I'm really excited to be part of the Soil CRC and honoured to be able to lead a program within the soil CRC, and my mandate is always to encourage, push, and increase knowledge, education, training, research in soil. So this is just one of the things that I do, and I greatly enjoy doing it. It's a big shame I can't get to meet you all. I have greatly into what happens. Tell me, Felicity, if anything goes wrong. But yeah, okay, so I'm heading up program 2, and I guess as the community of practice I've been engaged with from the beginning, so you guys know a little bit about what's going on in this program from discussions we've had, but not everybody. So I'll give you a quick snapshot. So all right, so this program is about soil performance metrics. So it's about, you know, how we measure how soils are performing, and make sure that those measures are appropriate, and to try and look at new technologies. So that's what the word metrics referring to. The other two words are clear enough. So there's 4 parts to how we'd like to do that, and one is to look at how performance is indicated. What are the things that it's, you know, wise to be looking at? And I guess, you know, these are around the biological functions and activities in soil, chemical and physical, including water and compaction and airspace and so forth. So what are those things that indicate that a soil's in good shape, steady state, or improving? And then, okay, great, having accepted those measures, how do we actually read them? How do we come up with gadgets and toys and inventions and existing technologies to make them better, to actually sense information in the field or close to the field or above the field, to get a data stream that can help us then make decisions following a level of analysis and interpretation, and bringing in other information and models. And then finally, given the technology we've got in our fingertips, in our hands, and that we're using now indeed, is to visualize, to be able to visualize that and express it in dashboards and guides for action that can be taken or not taken by a land manager. So within that, we're aiming within this program to try and move from more of a hindsight, looking back and looking at data sets, to bring those hindsight data sets together with modeled forecasting, to enable decisions to be made, you know, to better manage soil and land into the future. So yeah, bringing all the knowledge to bear, I guess. This hopefully will then enable, in a ever-changing world where social license is critical, and maintaining that into the future is environmental compliance, and that we're doing the right thing by the environment in terms of inputs and outputs from the farm. And also, we're looking at devices and ways that we can actually start to actually measure soil health better, and the fluxes and changes and trajectories of soil health. And I'll show you some of the things that we're trialing to work on at the moment. And then to enable, you know, better tactical use of farm input. So this is more, you know, around your precision agriculture, to be able to put the right amount of input at the right time in the right place, that idea. So that's what the program's about. So here are some of the workers, people in the program. So this is Dr. Stephen Cahoon.
Yes.
Can you see my mouse moving, by the way, folks, or not? Yeah, okay. And obviously, Michael, we know, and I've forgotten these 2 gentlemen, but they're visiting the Sense-T laboratory in Hobart last year. So in terms of the program, there's a range of projects that are currently funded on sort of 2 to 4 year timeframes. So if these go well, they might be expanded. There's other work we've got to do, which I'll highlight as well. We're not doing everything here. There is a little bit of a focus on the sensors technology in our current work. We did do some reviewing and assessment of the types of indicators that we could use early on, and completed that work. And then from that work and those meetings, we ran a series of workshops and meetings. We decided to go ahead with funding this group of 5 projects, and within, they're the ones that are going on. I'm getting another internet connection is unstable, so hopefully this continues okay. One of the exciting ones that a lot of people are quite interested in, and we've got a very enthusiastic scientist working on, is this attempt to develop a device that can smell the health of soil and pick up various gas emissions from soil and through time, and be able to see what they might be telling us about the function of microorganisms in the soil. And while that's happening, they're also looking at the makeup of those soils and their microorganisms, and that involves pushing the soil pretty hard. So waterlogging soil, cooling soil, heating soil, you know, getting various different types of soils, sandy soils, clay soils, organic soils, and seeing what sort of signals we get out of them. So it's highly experimental, and it's a proof of concept, and there's a prototype gadget that's been developed. The other ones, one of the ones being led by the University of Southern Queensland, is looking at carbon nanotubules and their capacity to provide us an ability to sense, you know, important ions in the soil. And this will initially be in moister soils under irrigation, or in higher rainfall environments, because you need the ions in the soil water to be able to make these readings. But yeah, Dr. Craig Lobsey, he's a mechatronics engineer, so this is an example of, you know, kind of non-traditional soil people being able to bring their smarts to bear on soils, just the way Catherine pointed out, that the need to understand the social context and how people make decisions and how markets might use soil signals to price or a product, or at least make a statement about the quality of a product, that it's looking after the environment. We're also bringing other people into the technology side. It's not just soil scientists anymore. So Craig's running that program, and Craig will be talking on Thursday. So hopefully you've received an invite to our program overview meeting, where I'll go through a few of these slides quickly, but I want to get to Craig and also to Dr. Marcus Hardy, that'll be giving an overview on the technical developments that are being made in these projects. So that's in-field sensing. We also wanted to put a little lab on a chip in a farmer's hand, or the consultant or user's hand. And so Dr. Liang Wang is leading a project that's bringing a range of technologies to bear on, you know, your traditional pH test, which would be colorimetric, and we all have different eyes and we read those colorimetric tests in different ways. What we want to be able to do is to take that color reading, to utilize mobile phone technology to actually read the color more in a standardized way, and to also locate the chip. We might have a barcode or something on it, for example, and to do that quickly, cheaply. These chips would be, you know, 10, 20, 30 cents each. And to also enable within the mobile phone the use of models which might guide addition of fertilizer mass or volumes or lime or whatever you're going to add to the soil, actually give you a suggested rate of application for that soil type. So it's quite an integrated project, bringing a whole lot of things together. Dr. Marcus Hardy is leading one of the larger projects within the program, and he's got a nest of projects that come under what we call smarter sensors development. So he's trying to look at, because farmers tell us through discussions with farmer groups that they like the use of the shovel, they like to feel the soil and walk through their paddocks and look at how things are going and do sort of self-interrogation. So he's trying to develop a smart shovel that can, the dream was to incorporate a moisture sensor, a strength sensor, and obviously a locational mapping sensor as a farmer interrogates his or her soils. So that's one component. The other component is to try and make soil moisture sensors smarter. Current days of soil moisture measurement really are limited to either measuring the water content in the soil, so the actual volume, mass of soil water, or gypsum blocks and other technology that measure the energy with which water is held in soil. So this has to be with capillarity and, you know, like this, the amount of energy. So you might have a wet towel, a wet sponge, and let's say, you know, I don't know, a wet tissue or something. They might have all got different porosities, so they'll hold water at different energies, but they might all say weigh the same, so they might all have the same water content. So it's the relationship between how water's held in the pore space as well as the water content that we need, because the plant sees the water energy. It doesn't care about the water volume, basically. It's got to suck the water out of the soil, but it does care, but we care about the water volume because we add irrigation, we add rainfall. So linking those two is critical, and no one's achieved it globally yet, so we're trying to do that. And the final one is to try and put communications from sensors below ground if possible, with long life batteries and various technologies to be able to send signals a short distance from underground to the surface, so that where cattle, wildlife, tractors aren't continuously ploughing up, eating and damaging underground sensors. So it's a pretty big challenge he's got there, and hence the large investment. So I've nested them there. You see those three are developing sensors. This first one's more around soil biology and soil health. That's more around chemistry and water. Dr. Peter, sorry, should I say, Associate Professor Peter Dalhurst from Fed Uni is leading a program which you can all click and log into on the CRC page. If you click the soil data button, he's already got launched the Visualising Australian Soils portal, and this is a portal to not just present traditional map information and data, which is useful from state agencies, but to actually enable all users, including farmer groups, to be able to share and see their data, and also have visualization tools to track how their soils might be going in terms of soil chemical data, which are typically getting done in a commercial laboratory. Commercial laboratories tend to just go from farmer to the lab, back to the farmer again. These aren't data that any state agency or larger body gets to see. So encouraging farmer groups to load their data and then choose who they share it with is the aim, was one of the aims of this Visualising Australia's soil data. So that's all terrific. We also had tried to fund a project, and we do need to consider how we will fund in the future a project that will work more on reliable biological indicators of soil health, because we keep hearing the need for these and the need for improvements in these, and both in what we might measure to indicate biological health, and secondly, to develop sensors to do such. Unfortunately, that project had to be withdrawn, and I'm hopeful that we'll call very shortly for expressions of interest around that once we've run all these various meetings. For more information on those projects, I do refer you to the CRC web pages. On the CRC page, there's quite a lot of information about each project and the project leaders, project team, and indeed all the farmer groups and industry groups that are involved in those projects. I also remind you of upcoming project meetings, and keep an eye on those as they come into fruition. Here's a few pictures of some of the projects that the program's working on. We can see at the bottom here the ENOs. That's a draft prototype there of that. At the top here, we can see the lab on a chip. This was work that was done a year or so ago by UTAS, looking at the chip. There's the chip. It's about the size of your thumbnail. There's a light box, and here's a smart camera that would read that. Here's a carbon nanotubule, and that's able to sense ions in solution. Don't ask me how the chemistry works, but we then put that into a on a probe, and that goes into the soil profile, and it can hopefully read ion fluxes through the soil at a range of depths, so we get a measure for nutrient availability status in the soil actively. This is just a screenshot because I live in Tasmania. I zoomed into Tassie, but this is the visualising Australian soils, Australasian soils, should I say. It's got data sets from New Zealand and obviously all the states of Australia. Here we can see the soil profiles from Tassie. So there's just a few pictures so you can see the physicality of what we're trying to do in the program. Indeed, here's the Vice Chancellor at UTAS and the Chair and CEO of the Soil CRC, all getting excited and encouraging the work. It's pleasing to say also part of the role of the CRC is to encourage and train the next generation of scientists across the sphere of soils, and we're proud to have 8 students funded. Some have started, some have yet to start. We need to take on more through time. Not all students pass. I think complete their PhDs. PhDs is a long journey of development and through research and mentoring, and they don't always come to fruition. So we've got 8. If there's about 50 to be funded across the CRC and 4 programs, we probably need closer to 20. But these are the 8 that we've got started. We've managed to get a range of students into these projects. Not all positions are filled yet. There's a couple around the soil biology area. One to do with microbiology tied to the ENOS project, where Phil Kay at UTAS, he started that PhD. At Southern Cross University, Naomi Wells has got a student. She selected a student to look at soil carbon and nitrogen pools and their impact on performance. So that's biology. In terms of the chemistry, there's a few PhDs tacked to some of the projects that I've already spoken of, so maybe I won't go through those in too great a detail because they're helping the work of those programs already mentioned, projects rather. And there's some, we're stepping away from the soil and looking at some of the satellite imagery with NASA that might aid in giving broad-scale soil moisture resolution maps, getting involved with drones and looking at perhaps the potential for some of the hyperspectral imagery. Initially, we weren't going to do this type of work, but we feel the investment of a PhD is a good way to have a test the water, as it were. This was to be done initially by the Smart Farming CRC, which didn't get funded. It wasn't. So in other words, we had an agreement with that CRC not to do this type of work, but given that didn't get up, we're starting to move into that area. And also drone-based, more work on imaging for soil health. So again, a good range of universities there. Yes, a little bit of a UTAS weight. I guess that has funded. It's not that it's a 10-year CRC. We're a few years in. It's good that we're making good progress in a few areas. But there's more to be done. Currently, there's a lot of focus on sensors, and that's part 2 or output 2 of our program. There's 4 outputs in our program. Output 1 is very much around what we ought to indicate and how we ought to indicate and how we work as a team to develop those indicators. And we've done a bit of work there already. But these are some of the things we still need to continue to working on exploring the interdependencies and relationships between various indicators and sensors. Often we're focused on one thing, measuring one thing, maybe water or soil temperature or nitrogen level. These things are interdependent, and sure, there's models that we also need to bring in, but the interdependency between indicators is important to continue to look at, be installed, and we need to keep the pressure on to keep developing those, and these are the key milestones within, again, that output 1. Within output 2, there's a lot happening. So this middle number refers to the output program. That refers to the program. This one refers to the output, and this is the specific milestone. So look, that second one is getting a lot of work, but what we aren't doing a lot on, we're doing a little bit, but some of the PhDs, I guess, will help. But the mobile mapping and sensors for spatial indicators, that's got a boost as these PhD students come on board, but I feel a little bit more work on that priority is needed. Program-wide data management and strategy is something we're thinking to come to, you know, get focused on the indicators, get focused on the sensors, but we're now starting to realize we're a little bit behind in how we handle these data streams and indeed how we help the entire CRC, not just our own program, bring data together to help with what I pointed out earlier, these interdependencies, these relationships between indicators, and how indicators can be enhanced with use of models. So we need to work on these milestones because I don't think we got the dates of those right, and we've been a bit asleep at the wheel at advancing that. But we have got a project that hopefully will get funded very shortly to start advancing and lead that. And I guess, again, we're seeing that with the smarter data analytics and the bringing of arrays of sensors and model responses to bear. So that's a bit more of the same, really. With farmers and providers, we've got to start determining, and this is into the future, of course, with challenges as pressing, but what's the best types of human interface technology, what's called HIT, and visualization of information, that we don't clutter, confuse, or provide overconfident, not validated visualizations and dashboards for decision making. So we don't want to be bamboozling farmers or coming up with tools that are of no use or aren't user friendly. So engaging with those farmers and providers is more work for us to do into the future. And that's where you guys would help us with that, advise us and become involved in projects in that area. Use of crop models, reliable crop models. Often they're used by academics and businesses, not so much by farmers, but how we bring crop models, machine learning from these sensor streams, multiple gaggles of sensors as these sensors are developed to enable one of those key aims of the program, which is to enable foresight-based farmer decision making. So with that, I'll just say that's where I'm at. I didn't put my phone number there, but when I email you, you'll see it on my signature. So that's where I'm at. So I'll move to question and answer, but maybe just before I do that, I'll just show you. I'll just minimize that. I'll just show you on the Soil CRC webpage just where that data button is. So here's the soil data button. If you click on that, that'll take you to Peter Dalhouse's project that he's leading. And as you see, it's Australia and New Zealand, and you can zoom on and you can find out. Click on, well, if I go to Tasmania, because I know Tassie, and I can click on the soil sites, and it'll show me where all the soil profiles are around my home. So I'm in Hobart, and I can click on one of those, and I can start to see some of the data. Okay, and I can view those observations. So that's there, but also I just wanted to get out of that one and go back to the CRC main page. Anyway, I can't get out of it, but if I've got myself a little bit stuck. What if I go back and I go back and I go back? No. I was hoping to go back to the main CRC page. I can't see which button to press, but there's a lot more.
Go up the top, Richard.
Yeah.
Go up to the top left hand
Oh, there it is,
of
yeah.
your tabs.
Yeah, I found it. Yeah. Thank you. Yep. That's what I encourage my students as we move into this online teaching, is you've got to help me as much as I help you. Thank you. So if you scroll here, there's awesome little videos that have been made that introduce you to the people behind these projects. And for program 2, you can see the range of projects that are there. So if we're looking at the visualising Australian soils, there's a bit of information there. That tells you everybody who's involved in those projects. That's a pretty highly participatory project there. And there's a little video normally from the project leader. So I think I'll leave it at that and go back to Q&A. Is that okay?
Thanks, Richard. That was really great. We did have a couple of questions in the chat.
Okay.
Keep getting it. So Marnie's asked, is there a starting point where you can teach farmers what the smells of soils mean?
Yes, that group are very much, we're hoping to actually come and bring their gadgetry and start talking to farmers and farmer groups at the conference. And I think they'll try and do that by virtual hookup. Yes, I think it's a journey for us to learn that as well. That's why there's a double-edged component to the work, and why we've got a PhD student is it's all very well getting those signals of various gaseous, CO2 and methane, whatever it is you're picking up, water vapor coming from the soil, oxygen. You also need to know what that might mean for what the bugs are doing. And that's why there's two components to the project. So there are people using traditional microbiological techniques to find out what those communities are that are active at the same time that you're getting those signals. So the answer is we're still learning that. And the answer is I would like a biological health indicator project funded so that we can have experts that are able to answer those types of questions. And that's one of the weaknesses of the program at the moment, is that unfortunately that project fell over, and we're desperate to find a new team and get a similar looking project funded. Hopefully that helps.
Yeah, so this might be too simple a question, but so the e-nose, is it measuring, gaseous substances? Is it measuring the amount of carbon dioxide in the soil? Is it measuring the amount of oxygen? Is that the sort of idea? Yeah. Yeah,
the idea was to buy existing gaseous sensors, volatile organic compounds rather. CO2, oxygen, you measure temperature and water vapor and things like that. So to buy what are already on the shelf cheap sensors, put them together in a device that's able to be put into soil and start reading those signals to see whether they link to the microbial behaviour in the soil. So I don't think this project can do it all on its own, and that's why we'll have a PhD. If it starts to make progress, it might be expanded into a future project potentially. But I guess what I'm saying to this group is, well, that project's going, and there's every possibility to get involved with it. I'd like to see involvement in a bigger soil biological health indicator and sensor type project. And so I'm interested in comments and discussion around that, and I think some of that discussion will happen as we look at how we adjust the milestones for the program, and that'll be an open forum next week.
Yeah, great. Someone's made a comment to say that Joel Williams, I think his name is, Joel Williams encourages people to smell their soil. So I guess,
indeed,
in a basic sort of sense, you can smell if it smells sort of freshish, or if it smells a bit stale, or
yes.
The thing.
That's where the project started. Dr. Bill Koching, who some of you may or may not know, is a very strong soil extension and research scientist who used to work with us in TR. Now he's retired, but he and I put it to the ARC, Australian Research Council, and it wasn't funded, but it got changed. And so there's actually a lot of global interest in this idea at the moment. Can you get a measure of the health of the soil without having to do the wet chemistry and the physics, the microorganisms as they function and behave, sending signals that say, oh, shivers, this soil's anaerobic, it's gone bad, we're dropping dead here, do something. Or reverse, oh yes, this is healthy, everything's swinging along here, we've got all the food we need and all the gaseous, environment and temperature we need to function.
Yep.
Felicity.
Yes, Marnie.
Hey, isn't this the biological health indicators one of the key things the Western community of practice wanted to create, and we've just found out it's a really big project sort of thing. It seems, I don't know, I just felt like that was a key thing that we wanted to kind of learn as a group, was some biological indicators, and it seems like it's a core project for the CRC.
It is, and don't feel you have missed out. It hasn't been funded. We had a core project that was to be led out of Victoria, and because of changes in the work environment, it's been withdrawn. So there's every intention that will be a priority that'll be advertised for new projects this year. That's my hope.
Yeah, you're right, Marnie. It's certainly an interest in the West Community of Practice, and it was brought up again yesterday in our Southern Community of Practice workshop as well, in regards to interest in, well, just an understanding of soil biology and that sort of thing. So we'll certainly be progressing our knowledge and trying to build our capacity in that area. Hopefully with the support, like Richard says, hopefully when that project gets some refunding, but I'm sure we'll still be able to progress the group's interest in that area all the same. So
it's my aim to run a short, virtual workshop on developing such a project, what we might do within the CRC partners. So I know this community of practice is mostly CRC partner organisations, but I think it's a bit broader than that. But all those that are partners would be welcome to be part of that.
Yes, we've got about 10 or 11 soil CRC partners amongst the 30 of us, but at this stage. But yeah, certainly the groups that are involved would be interested in supporting in whatever way possible. So thanks, Richard. Has anyone else got any other questions or comments they'd like to make? Any advice for Richard?
Someone would like the nose to look like a nose. Fair enough. It did have nostrils on it, I think.
Lots of little holes.
It looked like too many nostrils. Maybe a non-human nose. Maybe I should rethink what noses look like.
It's a bit pointy, and it's got nostrils. These are the little sensors, gaseous sensors here at the top.
Okay. All right. Nice one. So, thanks, Richard. I'm not sure if we've got any other questions, but if anyone thinks of anything during the time for the rest of the afternoon, just pop it in the chat and we'll be able to address it at some stage along the way. Thanks very much, Richard. That was great, and I encourage you to get in contact with Richard, and we'll certainly be calling on him in regards to his expertise and some of those projects that he's mentioned. I'm pretty sure the communities of practice are interested in a number of those projects, so we'll be looking forward to delving deeper into those. And like Richard said, the Soil CRC will be rolling out these conference webinars. Since we won't be having the national conference, public conference for everybody to get together, there will be these webinars, which hopefully all of you are on the mailing list, the newsletter list, so you should have received an invitation in the last couple of days, or yesterday actually, with links to those webinars. So let me know if you haven't received one of those emails from Michael, and they will be rolling out next week. So the first one, there's a couple I think on Monday, going through each of the programs, as well as a drought project webinar. That will be presented by Brian Hughes, who I had lined up to run some soil pits for the Southern group in the Barossa Valley yesterday. So you won't miss out on hearing from Brian if you want to hook into that webinar, which will be on the 8th of April. But yeah, let me know if you haven't received one of those emails. So they'll be quite good. They'll be delving deeper into a couple of the projects. And they're just hour-long webinars so that we don't miss out on what we might have been able to capture at the National Soil CRC conference. And I'll also mention that while Richard was mentioning it, the Visualising Australian Soils, they're having a web meeting this afternoon. And when I spoke to Pete Dowhouse about that meeting, he was keen for people to attend if they wanted to. We were going to attend the meeting in Adelaide, and he was happy for the COP participants to attend that. So if you wanted to hook into their webinar this afternoon, just let me know, send me an email, and I could send you the link to his meeting, so you can have a bit of an idea about how that project's progressing if you're interested. Thanks for those comments, Richard. So we're running ahead of time, which is quite nice, but I still encourage you to ask some questions and those sort of things if you'd like to. What we might do now is have, I think I had a 20-minute break scheduled. So we might take that 20-minute break now. Thanks, Michael, for your comment about when the first webinar is on this Thursday. Yep, fantastic. So we might take a 20-minute break now. We'll come back at about 2:05, and we'll be hearing about program 3, and that'll be Professor Nancy Boland from the University of Newcastle. So yeah, hopefully everyone's going okay. We'll take a 20-minute break, and I'll see you back here at 2:05. Thanks.
For the first 10 minutes, I will talk about program 3, covering the key issues, the research outputs, and the research projects. Then for the remaining 10 minutes, I'm going to discuss about our research relating to program 3, which is organic amendments and soil health. So first, what are the key issues in relation to program 3? Nutrients, water, pesticide, and soil amendments that include lime, for example, are the critical inputs required for improving soil health and function. These inputs contribute to the economic outcome of farm production. For example, in the absence of fertilizer input, the economic cost from reduced production is around 13 billion in in Australia. That's the annually. Therefore, the efficient utilization of these inputs, that is nutrients, water, pesticide, and soil amendments, is very critical to achieve the climate-driven genetic yield potential of many agricultural crops. So therefore, program 3 is all about new products to increase fertility and function. The CRC will develop new fertilizers, soil amendments to manage some of the soil constraints, and the delivery mechanisms for these soil amendments and also for pesticides to enhance the performance of these soils. Now, in program 3, there are 4 outputs. In each output, there are 6 milestones. I'm not going to the details of the milestones, but let us look at the 4 output. Output number 1, new targeted high performance fertilizer products. So the aim is to identify the most cost-effective methods of recovering and concentrating nutrients from waste streams. Just to give you an example, this is regarding phosphorus nutrients, which is a very important major nutrients, nitrogen, phosphorus, and potassium. And there is only limited source of phosphorus, which is rock phosphate. So there will be a time we will reach phosphorus peak. That means that the supply will reduce. To manage this, there are 2 approaches. One is either increase the phosphorus use efficiency by the crops, and also alternatively to increase the phosphorus recovery and reuse from waste streams. So phosphorus recovery from manures and biosolids will play an important role in meeting the future demand. So that's about output 1. Output 2, new targeted low residual pesticide delivery systems. It's all about producing porous material in which you can keep pesticides so that you can get a targeted slow delivery of pesticide. The pesticide delivery is very critical in improving the fertilizer use efficiency and reducing off-site contamination. It's a targeted delivery of pesticide to control pests, including herbicides. So that's number 2, output number 2. Output number 3 is novel materials to address surface and subsurface soil constraints. So the aim is to develop soil amendments. That's one of the aim. The second aim is to place the amendments at the right depth. Just to give you an example here, this is subsoil acidity, which is becoming a major concern. So we need to come up with materials which can be placed at the right depth. So one is the material, other one is the placement, machinery. So there are two components here. Coming up with new material, new products to manage soil constraints, and also the machinery to place them at the right depth. The fourth one is effective delivery mechanism for beneficial microorganisms. Here again, there are two components. One is microorganisms. You need to come up with new products to maintain the microorganism, to inoculate microorganisms, and also the products needs to maintain the moisture level, because one of the problem is when you introduce the inoculum, because of the climatic conditions, desiccation of microorganism is a critical issue. So survival of the microorganism depends on the water retention by these products. So the supply of quality peat, for example, is becoming a major issue. Therefore, we are looking for alternative material to maintain the microorganism. The second one is moisture retention is very critical for crop productivity. Farmers in Australia strongly believe the future is going to be all about growing under dry condition because of the climate change. So therefore, capturing every drop of water is very critical. So we are looking for products which can achieve that. So these are the 4 outputs. Now I will briefly go through some of the projects in program 3. We completed 3 projects, 2 scoping projects. One is waste-derived fertilizer products. The other one is soil amendments. The third completed project is called RAP project, Research Attraction and Acceleration Project, funded by New South Wales government. The reports for all these 3 projects are available inside Central. So therefore, I'm briefly go through the current 6 projects. The first project is new cost-effective methods to recover and evaluate high-grade fertilizer for organic waste streams. So the aim is to capture these nutrients and come up with a product which can be used as a source of nutrients. That's the number 1 project. Number 2 is to develop and evaluate nanoporous material to improve pesticide delivery efficiency. So the aim is to develop controlled release pesticide delivery systems. By loading these pesticides into nanoporous material. So in this case, we are testing the chemical used to control sugarcane beetle. So the aim is to come up with the porous material which can be used for other pesticide, including herbicide, so that you can improve the efficiency of these pesticides. Number 3 project is to come up with new products for microbial carrier. In this case, rhizobium carrier, which is the one we are using for nitrogen fixation in legumes. So currently we are testing a large number of carbon-based, clay-based, and organic-based products, as you can see from this bar diagram. So at the same time, we are looking at the water retention of these products, because that's very critical for microbial survival. The next project is products to manage subsoil constraint. In this case, organic-based gypsum and lime products to manage subsoil sodicity, acidity, and salinity. This is part of Output 3 project. So this project also includes the delivery mechanisms to place this material at the right depth. This is one of the project on sandy soil. Again, we are coming up with organic and clay-based material to improve the productivity of sandy soil. The 2 main issues with sandy soils, they are poor in retaining water, they are poor in retaining nutrients. Therefore, we need to come up with products that can improve the water retention and nutrient retention. The last project within program 3, currently in progress, is soil application of liquid biosolids for improving soil structure, fertility, and function. So the aim is subsoil injection of biosolid sludge application to improve the soil structure and fertility of soil through the application of this biosolid sludge. So this is about program 3. But before I go to the next aspect, currently we have around 6 PhD students in program 3. Some have already started, some are yet to start, to look at various aspects of these 6 projects. Now, Felicity, do you want me to continue for the second part, or you want some questions? Hello?
Sorry, Nancy. We haven't received any questions in the chat, but I'm happy
Nancy, can I ask you sorry.
Yeah, to open the floor to any 2 questions. Yes, go for it.
Felicity, before I do that,
Hey,
I have another
Nancy,
10 minutes
Nancy,
of
I just wanted
presentation.
to ask about the...
Hello, Felicity?
Yes, Nancy.
I can't hear.
Oh, okay. I've taken my mute off. Can you hear me now?
Yeah, I can hear you, but not the question.
Sorry. Sorry, it was just a quick question, Nancy, about the sludge. It looks like a cleanaway truck in the presentation, just straight from picking it up. Does it get processed or something before it's injected into the soil?
Exactly, it has gone through the processing. It has reached the stage for injection because it is under EPA Victoria regulation. So it has been maintained in the pond, but it is still a sludge, but not as a biosolid. So the contaminants, the E. coli level, microorganism level are below for injection. So it has been approved by Victoria EPA.
Thank you.
Felicity, do you want me to continue? Or?
Yes, you can continue.
Okay, that's about the first part of CRC. The second part is some of our research in relation to organic amendments to promote soil health and productivity. So in this presentation, I will briefly introduce the sources of organic amendments, the multifunctional values of the organic amendments. Then I will talk about the value of the organic amendments in improving physical fertility, chemical fertility, biological fertility, or biological health, and some conclusions. Now, organic amendments include a range of products. They come from living organisms, which is plants or animals. Around 6 million tons of organic material is produced in Australia. This is according to 2011 statistics. So you can see in the PowerPoint presentation, they can group into manure compost, green waste compost, farmyard manure, vermicompost, biosolid, which is the sewage sludge. Now the recent product, biochar. So this is one way of grouping them. Now, organic amendments have multifunctional value, improving the physical fertility of the soil, chemical fertility of the soil, biological fertility. They can be used to store carbon, carbon sequestration. They can be used to manage soil remediation. If the soil gets contaminated with PAH, you can use compost to degrade them. Organic amendments can be used as a nutrient and microbial carrier. For example, biochar is increasingly used as a nutrient enrichment. But today I'm going to talk about physical fertility, chemical fertility, and biological fertility. So one is a meta-analysis. It is a statistical approach. So meta-analysis can be used to identify and compare common treatment effects among a number of studies. This will provide quantitative information. In this case, on the effect of organic amendments on some of the soil properties. Because I'm going to use this slide for the next, I'm going to use this diagram in the next few slides. I'm going to explain to you what it means. On the x-axis, the percentage change in soil properties. Treatment, which is organic amendments, minus the control. Positive values means increase in soil properties. Negative, decrease. For example, so that's the soil properties. This is the change in soil properties. For example, if you take microbial biodiversity, by adding organic amendments, you have increased microbial diversity. All are positive. So these dots are the data points from number of studies. And the arrow is the range in the values. In this example, the microbial diversity is increased by around 5% to more than 20%. That's what it means. If you look at hydraulic conductivity, in some cases it increased, in some cases it decreased. I will explain later. If you look compaction, most of the time, by adding organic amendments, you decrease the compaction. That's because you decrease bulk density. So this is the kind of diagram I'm going to use in next 3 or 4 slides. You can see we examined around 360 studies. We grouped them into the organic amendments into manure compost, green waste compost, farmyard manure, vermicompost, biosolid, and biochar. So in my remaining presentation, I'm going to look at how these organic amendments impacted physical, chemical, and biological fertility. However, yes, please.
Can I ask what the manure compost was made of?
It covers a number of them, all the way from cow manure, chicken manure, poultry manure. They are all grouped into manure compost. Because the data come from around 360 studies, we group them into different organic amendments. Now you can see the effects varied with organic amendments type, the effect of these material on physical fertility, chemical fertility, biological fertility depends on the type of organic amendments, the level of application, the soil type, and environmental conditions. In meta-analysis, we can look into each one of these components, but I'm not going to provide that detail. In next few slides, I just show you how these different types of organic amendments impact various soil properties. So this is about physical properties, penetration resistance, which is compaction, aggregate stability, which is soil structure, and bulk density. So in this diagram, this part is increased, this part is decreased percentage due to organic amendment application for manure compost, green waste compost, farmyard manure, vermicompost, biosolid, and biochar. So you can see that compost application improves soil physical properties. The bulk density decrease, that means less compaction. Aggregate stability increased, more structure, better structure, and bulk density is part of the compaction, so bulk density also decreased. But one of the important aspects here is the effect depends on the nature of the material. For example, you can see biochar, the aggregate stability due to biochar is less compared to other organic amendments. So the effect of these amendments on many properties depend on the nature of the material. Just continue on physical properties. This gives water-filled pore space, that is the porosity, hydraulic conductivity, there's the flow of water into the soil. You can see in all cases, both water-filled pore space and hydraulic conductivity increased with organic amendments, except in biochar, there is a decrease in hydraulic conductivity because biochar can block the soil pores because they can be very fine powder. Thereby, it can reduce hydraulic conductivity. However, in most of the cases, it increased water-filled porosity, hydraulic conductivity. So based on that work, we did some work on water holding capacity. That is water holding capacity, not water holding. Sorry for the typo. So we look at a sandy soil and a clay soil. This is control, manure compost, green waste compost, farmyard manure, vermicompost, biosolid, and biochar. Organic amendments increases the water holding capacity because they can hold more water. The effect of organic amendment application was higher in a sandy soil than clay soil. One of the projects in program 3 is to improve the water retention of sandy soils. So they will be looking at some of these products. Now let us look at chemical properties or chemical fertility. The bar diagram gives the nutrient concentration, nitrogen, phosphorus, potassium, and sulfur in some of the organic amendments: manure compost, green waste compost, farmyard manure, vermicompost, biosolid, and biochar. So you can see that in all cases, the concentration of nutrients in soil is increased. That's because all these organic amendments contain nutrients. So by adding them, you increase the nutrient content concentration in the soil. Of course, the increase depends on the nature of the organic amendments. Biochar may not contain much nutrients, so it may not increase the nutrient content compared to manure compost. The second one is, these are the three important chemical properties: electrical conductivity, which is salt concentration, pH, cation exchange capacity. So you can see that organic amendments increases the cation exchange capacity, which is negative charge. Cation exchange capacity in soil is very important because these will hold on to nutrients like potassium, so that thereby you reduce the leaching. Electrical conductivity, which is salt concentration. Majority of the manures have salt. Therefore, you increase the salt concentration in soil, which may not be good for the soil. But the effect is not as significant compared to a saline soil. In relation to pH is very interesting because organic amendments can act as a pH buffer. It can increase when the pH is low. It can decrease when the pH is very high. So they have the capacity to buffer the pH. So they can be used as a liming material. Finally, the biological properties. We measured respiration and enzyme activity, a microbial biomass carbon. So you can see in all cases, organic amendments improve soil biological activity as measured by these indicators. Except in the case of biosolid, there was a decrease in enzymatic activity because biosolid can contain some heavy metals. Because these come from a number of studies, the arrow gives the range in the percentage increase. So you can see in this case, the enzymatic activity decreased to around 12%. But in some studies, it increased up to 20%. So that's the range in. So what are the conclusions? What are the take-home messages? These are the take-home messages in relation to organic amendments. Organic amendment application improves soil health, thereby increasing crop production and reducing the environmental impact of nutrients. Organic amendments is mostly used in horticultural and landscaping systems. More field studies and cost-benefit analysis are required under broadacre farming systems, because that's where organic industry wants to get into. The real challenge in organic amendments is the consistency of the product, and the quality of the product, and the cost of organic amendment products. So that's where the real challenge. So we need to concentrate nutrients in organic amendments so that you can use organic amendments as a nutrient source also. It is not going to replace chemical fertilizers. It can definitely supplement. But the value is beyond nutrients. The carbon value, the microbial value. So finally, I would like to thank Soil CRC and Felicity for organizing this, and my past and present students. Thank you, Felicity. I took a lot of time. Thank you.
No worries, Nancy. That was a very good presentation, and I know that the community of practice participants are very interested in this topic, and we have had some questions posted in the chat. So I'll just read those out. So the question about the situation that it will work in. So you've made some comments about use in horticulture and landscaping. The participants are interested in what sort of rates we use and how long the benefits might last, particularly in a probably a broad acre situation. So have you got some comments? I know that was a meta-analysis, but what sort of rates and how long do you think those changes, those benefits will last, Nancy?
Thank you, Felicity. That's a very good question. In relation to the level of applications, from this around 360 studies, the level varied from 2 tons per hectare per annum to 10 tons per hectare per annum. The 10 tons is very intensively farmed horticultural cash crops. Normally, the application rate is around 2 tons per hectare. So that's number one. Number two, in relation to the persistence or the long-term benefit of these organic amendments in relation to these soil health values. When it comes to the physical health, for example, aggregate stability, aggregate stability can sustain for much longer time under no-till condition than cultivated conditions. Whereas the improvement in chemical properties like increase in nutrient concentration is only a short term, because as the plants take up the nutrients, you need to provide additional nutrients. So what I'm trying to tell you is that how long the benefits will remain depends on the level of application and the nature of the properties, whether it's physical or chemical or biological property. Thank you, Felicity.
Thanks, Nancy. And there was a question about, there are a few farmers already having a go at using organic amendments. Your project team are working with landholders and with farming groups to implement these projects, is that right?
Certainly, Felicity, we had a major project, RAP project, research attraction and acceleration project. The project team worked extensively with the farming groups and farmers, and also in project on sandy soil, number one, and also the project on subsoil constraint. We are working with a number of farming groups to look at these values under field conditions.
Great. And we've got a landholder in North Central, and I noticed that somebody also mentioned it, that some landholders are using compost extracts or also worm casting extracts. Are you looking at those, Nancy? So they're actually, rather than putting out the worm compost as a dry, they're actually putting it in water and extracting stuff out of the worm compost. Will you be looking at that sort of thing as a study?
Thanks, Felicity. In this project, we are mainly looking at the solid-based organic amendments, but I do understand about they call it vermicompost tea. I know some of the extract, they're trying to use the extract, but in these studies, we are not really looking at these extracts. However, in the project in which they are trying to recover phosphorus, we are looking at farm effluents like piggery effluent, dairy shed effluent, and sewage effluent to recover the nutrients, phosphorus. But in relation to compost, these projects are not exclusively looking at the extracts, mostly focusing on solid organic amendments. So in the meta-analysis also, we look at mostly solid organic amendments, because some of this extract they are using as a foliar spray. It's pretty difficult to look at the effect on soil properties.
Yeah. Some of them are also injecting into the soil, but yeah, good. Okay, Nancy, maybe that's something. Just thought I'd mention it. Something that could be looked at in the future, or something like that.
Yes, certainly, it's a very, very interesting topic. You know, the vermicompost tea, for example.
Yes, exactly. Yeah. Thanks so much, Nancy. That was a very thorough introduction to Program 3, and I'm sure we'll be calling on you for to delve deeper into those topics as we progress with the community of practice. So thanks very much for making yourself available, and thanks to the group for your questions and both.
Felicity, just a question, because you know, we talked about this PowerPoint presentations, pretty massive presentation. Were they able to download it? Or are they able to follow? Or are there any trouble? Or?
I don't think there are any problems. People made comment about your great gifts. They're pretty happy to see some of those gifts. They were entertaining. So I think everyone was able to follow. Thanks, Nancy.
Thank you.
Yeah, good job. All right, so I'll introduce Lucas now, Dr. Lucas Van Swieten from the Department of Primary Industries, New South Wales, who will introduce Program 4, which is based on integrated and precision soil management solutions. And Lucas, I understand you might be tag teaming with Felicity Gilbert, so I'll leave it with you, Lucas, if you'd like to introduce the program. Thank you for coming along.
Thank you, Felicity. Can you guys hear me okay? How's my audio coming across? Excellent, excellent. So hopefully this is going to work. So I go here now and I go share screen. Is that correct?
Correct.
And
choose your screen.
And I'm assuming that everyone can now see. Now, for some reason,
share now. You have to, down the bottom right hand, it says share now. So you click on the screen and then share now.
Okay, I've just had a problem with my PowerPoint. For some reason, it's crashing every time I go into full screen. So I might need to live with a, okay, I can go share. And can everyone see my sharing?
Yes, yep. So
excellent.
just just make it a full screen and make it a presentation. Can you click the slideshow down the bottom?
So hopefully this will work. I've just tried it then and it crashed my PowerPoint. So
okay.
I don't know what's going on. There must be a conflict here somewhere. Okay, probably everyone's seeing a blank screen now.
Yeah, it looks like it's something's going around and around though. No, just a black screen.
Okay, that's all right. I think we're just going to have to live with me going through it as a, oh dear. It's a little bit unfortunate.
Yeah.
How about I make this as big as possible? Is everyone okay with that?
Yep, that's okay. Yep. You can close that document recovery panel, perhaps, on the left.
On the left. Oh, yeah, close that. Yeah. I guess this is as good as anything. Thank you very much, Felicity. And I also have Felicity Gilbert from Wheatbelt NRM as a guest speaker today. So I noticed about 20 minutes in the agenda, so I'm going to get through program 4 pretty quickly because I think it's quite important for Felicity Gilbert to have a bit of a discussion around the regenerative agriculture project that's currently in program 4. So I'll get through this content as quickly as I can. Okay. Right, just a little bit about me. I didn't see the introduction from the other speakers, but that's me sort of in that right-hand side there, just showing that I am actually able to shovel manure. That was in a project in South America. I've been with New South Wales DPI since 1995, initially working on contaminated soils from catalytic dip sites. I'm currently the director of Wongbar Primary Industries Institute, and I've got pretty close linkages at Southern Cross and Griffith University. I also spent 2001 in the US as a part of a Churchill Fellow, and importantly, I think for a lot of the attendees here, I'm actually a farmer as well. So we grow custard apples, figs, garlic, and cattle in northern New South Wales. So I'm quite familiar with tractors and implements and other things. So I guess the problem with a lot of our soils is what's known as, or the outcome is, the yield gap. So this is an initiative between CIRO and GRDC, and there are lots of really good maps showing the yield gap. In this case, it's from wheat. And there are some regions, if you look at the Eyre Peninsula, for example, other areas in central Victoria, western Victoria, the yield of wheat is much lower than what's expected given a particular rainfall. And that particular yield gap is due to some sort of soil constraint. So what causes soil constraints, or what actually causes a yield gap? So here's a classic example of a sodic soil. So in the top right-hand panel, you can see water ponding on the surface. And in the bottom, I think Nancy sort of talked about water infiltration and hydraulic conductivity. A classic example here is, on the left-hand side there, you can see a soil that allows water infiltration. It basically is well aggregated, it's non-dispersive. You go to the right-hand side, you've got a highly dispersive soil, and this dispersion is caused, in this case, by sodicity, where you have lots of sodium floating around in the soil, can also be potassium floating around in the soil. And what that does is it basically collapses the clays. So in particular, the clays that are 2-to-1 clays will often be dispersed by the sodium or the potassium, and they impenetrable barriers, and that's why you get water ponding on the surface. Another outcome there is obviously, the soil becomes more compact. It's very hard for root penetration. There are a whole stack of issues associated with subsoil and surface soil sodicity. Nancy mentioned other issues like salinity, for example. So there are a very, very wide range of soil constraints. Another particular soil constraint that we're working on in the soil CRC application, And I'll talk very briefly about that project in a little while, but it is also a fairly significant cause in some years of crop failure and lower yields. And on the right-hand side there, I've got a little diagram of what acid soils can do to a canola root. And in this particular case, it's not the acid itself, it's not the low pH that's causing the problem. It's at low pH in some soils, not all soils, but in some soils where you have low pH, you tend to have high exchangeable aluminium. And aluminium is quite toxic to the root systems, and it causes stunting and thickening or callousing of the root. And by having thickened callous roots, accessing nutrients, and basically you're limited to a much smaller pool of water and pool of nutrients in your soil, or the bucket size is smaller. And some economic considerations. I think annually is estimated subsoil acidity costs around about $1.6 billion, and subsoil sadicity is around 600 million. So it's a fairly significant economic barrier in broadacre agriculture. So a lot of what I'm talking about today is going to be based on, in particular, broadacre agriculture, but the findings are also quite relevant, I think, in horticultural systems as well. And I'm going to start the slide off with an example of success where you've got integrated solutions. So this is a fairly successful farmer in Western Australia at Witnoon Hills. And on the left-hand side, you can see a fairly healthy canola crop. And it has been both spaded and delved. So basically what they've done is they've brought up clays from the subsurface and they've mixed that well through the top, probably 20 to 30 centimetres of soil. And on the right-hand side was their control where they didn't do it. And got quite poor water penetration. So these particular soils are non-wetting. And I think everyone here understands what a non-wetting soil is. So this is a good example of a successful integrated solution to fix some pretty serious issues. A little bit about Program 4 for the soil CRC. So essentially it's divided into three outputs. The first output is novel plant and systems-based soil re-engineering methods. So I'll go through that shortly, exactly what that means. The second output is around physico-chemical based soil re-engineering methods. That's probably a little bit more, traditional, where we're looking at the use of gypsum and lime and new products that Nancy was talking about in his project. It could also include organic amendments, essentially to address some of these soil constraints. And the third output is around universal soil re-engineering decision support tools. So, for example, it's impossible for us to make accurate assessments for, say, lime rate for every particular soil in the country, if acidity is a particular constraint. But through modelling approaches and through some of the tools, they can certainly help us guide better decision-making systems. And again, I'll mention some of the projects happening under that particular output very soon. So a project that I'd like to talk about now is one that's led by Terry Rose at Southern Cross University. And this particular project is very much based around use of rotations, intercrops and cover crops to basically shape the soil rhizosphere. So it's very much around, what can we do to the rhizosphere to improve soil fertility, improve nitrogen retention, for example. So one of the issues, and this particular photograph is at one of our partners in far north Queensland. So that's at Lawrence de Bella's, one of his properties under his control. And one of the issues in some of these farming systems is there are periods of time where there's actually no crop in the ground. And those particular periods of time are also susceptible to leaching of nitrogen, for example, or volatilization of nitrogen as a greenhouse gas, nitrous oxide. So part of what this particular project is trying to do is, if we grow a cover crop there, for example, can we capture that mineral nitrogen that would be otherwise lost in the soil and convert that now into what's known as potentially mineralizable nitrogen. So basically you're storing that nitrogen in organic matter that you've grown on the field. And when that organic matter breaks down through natural microbial processes, through mineralization, that nitrogen then also remineralizes and becomes plant available. So, you know, they're looking at in particular the nitrogen cycle at that particular farming system, having a look at the mechanisms of why cover crops and intercrops actually work. And it includes a fair bit of work around looking at the rhizosphere microbial community as well. So this particular project is doing some techniques known as metabolomics. So different plant species release different exudates through the root system. So for example, sugarcane has got a fairly simple profile. It releases a lot of simple sugars into the soil. Whereas if you look at a legume, they tend to be more complex, and that complexity of the carbon input into the root system means that you tend to get a more biodiverse and more complex rhizosphere community as well. And this particular project is going to try and resolve whether that more complex rhizosphere community can impact or benefit the crop. So here's an example of that plant root neighbourhood. Now, apologies, I don't know how well that's come up. So this is taken from a fairly recent publication, and I guess some of the theories that that Terry's using here is based on some of this work. So on the left-hand side is a wheat crop, and you can see that the roots growing straight down. On the right-hand side, you've got a legume, and in the middle, you've got a maize, again, another grass. And again, it's not that obvious, but what's very clear from the outcome here is that the maize crop, or the maize plant in this case, in this rhizobox, its root system is naturally drawn to the legume root system. Now, this has got nothing to do with the nitrogen content. You know, it was a non-N-fixing legume. It wasn't inoculated. It was all around you know, the legume and the grass here, the maize crop, had a symbiotic, I guess, a symbiotic association whereby there, you know, maybe the roots had a handshake agreement through the soil biology, and that particular outcome is something that you know, Terry's project and some of the PhD students that are working on Terry's project will be resolving. And here's another example of a fairly successful intercrop. So this is tea tree. So it's a harvested perennial tree crop, and intro Terry Rose was growing legumes. And essentially what they were showing was that they get improved nitrogen availability and also improved nitrogen transfer mechanisms from the legume into the tea tree crop here. And the farmers actually adopted that practice, and they're quite happy with it. Another benefit is it also helps to suppress some of the unwanted weeds, and the legumes are actually fairly easy to spray out. So, you know, when they are starting to compete for water, you know, a sniff of 2,4-D over the top of it takes care of the legumes quite nicely. Another project around Output 1 is co-innovation in regenerative farming systems, and that's a picture of Gwen Greelett. She's based in New Zealand, working on the Soil CRC project. I'm not going to go into too much detail here because I'm hoping Felicity Gilbert can give a bit more of a background on this fairly important project within the Soil CRC. And another project is led by Mehran Rashdi, also with Professor Chen from Griffith University. And this particular project, I'm going to have a look at this slide. I've only just received it from Mehran, but it's essentially looking at soil resilience and soil vulnerability. And there are hundreds and hundreds of ways to measure soil biology. You know, when you add an organic amendment, for example, sometimes things go up, sometimes things go down. You're never quite sure exactly what that means. But what we're particularly interested in, where a soil might be exposed to a stress factor, and that stress factor might be lack of water resulting from drought. That stress factor might be compaction, for example. And Mehran and his PhD student, Zhangyu Lu at Griffith, have done a lot of work around compaction. And what they're showing is that soils that are more resilient, and that could be due to higher organic carbon content, it could be due to improved pH, tend to bounce back more quickly when these stress factors are alleviated. So, for example, when you release the compaction stress, they tend to start functioning more quickly than a soil that's less resilient. So there's a fair bit of work still to do on actually developing the metrics around soil resilience, but I'm hoping that at the end of this project, we'll have a really neat way of actually being able to say a particular soil is more resilient than another particular soil, rather than just measuring a whole heap of biological indicators. We actually have a more useful criteria for resilience. Okay, there are lots of reasons that you would amend. Key reasons to amend soils is to improve the available plant available fertilizers in that soil. You might amend soils for pH and aluminium toxicity. You might amend soils to fix up salinity. Nancy put a lot of effort around explaining structural properties and cation exchange capacity, and certainly composts and organic amendments and gypsum are very useful amendments to address poor structural properties. Soils might be amended to alleviate issues around contamination. That contamination might be organic contamination, for example, a residual herbicide. It might be a metal contamination. Soils are also amended for soil-borne diseases. So you can use fungicides, and in horticultural systems, there's been quite some success around using particular composts to lower the stress from soil-borne diseases. And another reason, as I mentioned a bit earlier, to amend is to improve the soil resilience and soil function. I guess one of the questions here is also how economically viable are these amendments? And it's certainly possible for us to make, from scratch, a very, very good soil. Almost disregarding what our starting material is, but is it ever actually going to be economically viable? So, some of the projects around output 2 are looking at these multiple constraints. So often these constraints don't happen in isolation. Often you'll have multiple constraints that a farmer needs to prioritise around what they're actually going to address. Are they better off putting their money into fertiliser? But if that's not the limiting factor, if it's aluminium toxicity, would they be better off addressing the low pH of the soil first before they add the fertiliser? So there are a whole stack of quite complex questions that farmers, I think, and agronomists and advisors often have a degree of art in, and they kind of know the best way to address it. And obviously that comes with experience, but hopefully what we're going to do here is have a little bit more science around multiple constraints and the best ways to address these. And this is Jason Condon from Charles Sturt University, who's got a project in output 2 from program 4, which is around understanding the mechanisms of amelioration for these multiple soil constraints. And they have they've addressed they've now collected quite a number of soils. I think it's maybe 20 or 15 different constrained soils from the various grower groups associated project. So it's a fairly large project with regards to the number of collaborators there, and they've got nutrient deficiency, boron toxicity, sodic saline soils, potassium deficiency, magnesic soils. So there's quite a range of soil constraints that they're setting up incubation studies and basically pot trials in controlled environment studies to look at some of the best ways to address these particular constraints. And it's very much around delivering evidence for growers and advisors. And I think what's important here with this project as well is that some of the outcomes from this will also be delivered into output 3, which is around the which is focused on the universal decision support tool. So if we get a better understanding of the mechanisms and we understand why things are working, then we can start delivering better tools that farmers and agronomists can use. This is Mick Rose's project. He's at New South Wales DPI. I mentioned earlier that that residual herbicides, in particular, some of the IMIs, for example, where you might be coming out of a clear field cropping system into more traditional cropping systems. Now, some of these herbicides can last much longer than what the label states, in particular where you've got low microbial activity in soil. So again, these herbicides in soil break down or dissipate mostly due to microbial activity. What drives microbial activity? Carbon content, water and temperature. So, you know, that top right hand corner there where you've got a very sandy soil and you've had a drought, not a lot of microbial activity, these particular chemicals hang around for a long time in those soils. So part of this project is around developing some models to better understand the dissipation rates of these chemicals in these soils, and in particular how the weather and the climate at that particular site or that particular region can influence the carrier over of these chemicals. And also what is completely missing from the whole picture are toxicity thresholds. So while we can very accurately measure the concentration of, in this case, chlorpyrrolide, but any of the other herbicides that are causing some issues, while we can very accurately tell you what the concentration is in the soil, we don't actually know what it means. So, if you've got a heavy clay soil with a bit of organic matter in there, most of these chemicals are not bioavailable. Therefore, they're unlikely to cause issues with plant back. If you've got a very sandy soil, low cation exchange capacity, low organic carbon content, these chemicals remain in the soil solution, and very low concentrations of the chemical can be taken up by the crop, and it can cause them to fall over or cause a yield gap. So part of what this project's attempting to do is to deliver improved models and improved understanding of the toxicity thresholds. And onto the universal decision support tools. So this particular project is led by Keith Pemberton from University of Southern Queensland, again with quite a number of collaborators on that project. And the first component of this project was around prioritising the soil constraints that the grower groups have identified, and essentially looking at existing models, so APSIM, for example, or how leaky, and how can these particular constraints be adequately represented, in particular in APSIM. So I think they're tending to fall back to APSIM as the modelling program of choice, and essentially it's going to allow better representation of, for example, phosphorus fertility or sodicity or low pH through these particular models. And a part of the model development is around ground truthing, sensibility testing and improvement. So I think there's going to be a lot of discussion with our grower groups and using collective wisdom to essentially to ground truth how these models work in the field. Are they useful? What needs to be improved on them? Now that says essentially the same thing, sorry about that. And some other outputs from Program 4. We've got, I think right now, 7 field trials associated with Program 4, and there's about to be another 6 being established. So a part of what we're trying to do now is to get as many grower groups together, because there's a lot of benefit in getting the grower groups together on a field site, looking at some, more often than not, common issues, common problems, and hopefully some more common strategies to address these particular issues. So we'll be hosting quite a range of farm walks and demonstrations coming out of Program 4. I think that's it, Felicity. Maybe I could take questions now, and then we could hand over to Felicity Gilbert.
Yeah,
does that sound fair?
That'd be great. Thanks. Thanks, Lucas. We did have a question about the acidity, the cost of acidity. And is the cost of acidity mostly related to the impact of aluminium? Do you have an opinion
it can
on that,
be,
Lucas?
but it's not always. So low pH on its own can cause issues. So the H plus of protons on their own can cause issues. But again, depending on the soil type and the mineralogy of the soil, more often than not, it's also associated with aluminium toxicity. So some crops are quite aluminium tolerant. Other crops are highly susceptible to aluminium. So, it's quite important to, as a part of the cation exchange testing that many farmers and agronomists and advisors would do, to actually check what your aluminium saturation is in soil, and to make sure that it's below a threshold for the crop that's being grown. And if it's not, it's probably going to be quite important to address that aluminium toxicity. Now, remembering, and I think Nancy mentioned it, it's a project that's I think being led by Ehsan Tabakoli. Lime is not all that soluble, and it needs a lot of water to dissolve lime, and it actually takes a long time for the effects of lime to penetrate deeper into the soil profile. So if you've got aluminium toxicity at 20 centimetres or 30 centimetres in soil, surface applying lime might take a long time to actually show benefits for that aluminium toxicity. So, I think it's quite important here to look at these integrated solutions, different mechanisms for delivery, for example, and even new products where, some of these lime products or gypsum products might be micronized. They might be associated with organic matter, as Nancy mentioned, and they're more likely to flow through the soil and act at the region where they're needed. So it was a great question, but there's unfortunately no simple answer to that.
Yeah.
So, a comment there?
Sorry.
Am I allowed to comment on that?
Yes, go for it, Richard.
I mean, aluminium is the key driver of soil pH and its behaviour, because at soil pHs it can quite readily hydrolyse, mopping up the opposite of hydrogen ions. The concentration of hydrogen ions is the problem, but if you're consuming hydroxyl ions by aluminium mopping them up, it ends up being the master variable that controls pH in most soils, because most soils have, in Australia anyway, a fair bit of clay in them, or clay in them, any amount of clay, and clays are basically, half of them are made of aluminium. They're aluminium and oxygen. That's one layer of a clay, and the other layer of the clay is silica and oxygen. So usually there's no shortage of aluminium. So it's a key driver. The exceptions would be organic soils or very sandy soils, where it would be more driven by hydrogen ions themselves.
And in that particular case, Richard, I was thinking, in WA, where you do have some of the very sandy tennisols, the highly sandy soils there.
But those cases, the pH is less of a problem. So you might have a similar low pH, but it's less of a challenge because you don't actually have the main problem that comes with it, which is the aluminium.
That's right. And the main issue with the acid soils is the aluminium.
Yeah. So if you have a sandy soil or a peaty soil, in a way you can forget about the pH. It's not actually an issue.
Mm-hmm. And I guess on the flip, sorry, Felicity, I was just going to say, and on the flip side, you've got the highly alkaline soils as well, where other things start becoming toxic, for example, boron in pH 8.5 soils, some of the calcareosols and the highly calcareous soils around the Eyre Peninsula, they too can be problematic. So, it's got nothing to do with aluminium there, but there are other elements that can start causing toxicity.
Yeah, so Helen from Central West Farming Systems has made a comment that she thinks that their low aluminium in some of their soils make farmers believe that lime doesn't pay because they don't see a response. Could they have that sort of on the edge of an acidity problem but still have low aluminium? It's not necessarily impacting production.
So what I would recommend in those particular cases would be to check what the aluminium saturation is and where it is as well. So, if it is in the surface, say the 0 to 10 centimetre profile, liming the surface can probably address that. If your high aluminium is at 30 centimetres, again, you're not going to see a response from lime, at least in the short term. That's going to be a very long-term investment.
Yeah, so Helen suggested that her aluminium is less than 2%, and I'm assuming that's in the top 10 centimetres of the soil.
Yeah, that's
So
yeah,
that's quite low, really.
Yeah. Okay. Right, well, we might bring Felicity in for 5 minutes to give us a rundown on the regen ag component of that project. Thank you very much, Lucas. And if anyone's got any other questions that they think of while Felicity's talking for Lucas, please pop them in the chat. Thanks, Felicity. Have you go for it.
Thank you, Felicity. It's unusual. We don't have the most common name in the world, so it's an unusual situation. Yes, the CRC project that we're involved in is looking at how carbon functions within regenerative farming systems, and I think it's a particularly exciting project to be involved in at the moment, because regenerative farming is so hot right now, and everybody's interested in it. So I think the timing is really good. We've got 4 major partners in the project. The project leader is New Zealand Landcare, Gwen Gretlett, as you saw in the presentation that Lucas gave. We also have Wheatbelt NRM, Soils for Life, and the Department of Ag in terms of South Australia. So our project partners are really diverse, which I think it brings some challenges to the project, but it also brings some clear strengths as well, because we quite often are coming from quite different viewpoints, and I think that diversity actually helps us plan better projects. The project is fundamentally, sorry, I'll go back one step first. The first thing that we did was pull together collectively. I should say that Nicole Masters is also, many of you would know Nicole. She's very well known in regenerative agriculture. She's also a part of the project team that are designing the project, and so collectively we all got together and identified the farmers that we believe are furthest along their regenerative journeys across Australia. And we approached most of those to ask them if they'd like to be part of a project reference group, and it was terrific, because they all have agreed to come on board, and we've got a pretty amazing group of people involved. We went about the co-innovation platform. Part of the project is about actually speaking to the farmers about what the sorts of indicators that they use to determine how their systems are functioning, recognising that regenerative farming can be quite different from traditional methods, and the things that farmers are looking at with their systems as their signs of success, they're not necessarily the same things that conventional farmers are looking for. So we're starting from that premise, and we've been through an extensive surveying process to try and tease out what are the most important things for them, with a particular focus on carbon functionality and how that works in the system. We're also focusing more in the project on cropping and grazing integrated systems. We looked at a range of different possibilities, from sugarcane through to high rainfall grazing, and we decided that probably the most challenging area in many ways for regen systems is in the medium to low rainfall zones in and sandy soils and things along those lines. So can anybody hear my daughter who's home from school in the background? I might just hear 1 second. Maddie, I'm on a work call. Can you shut it? Sorry about that, guys. The challenges of our new COVID environment. So where we're at the moment is trying to develop the paired sites, and that in itself is proving very interesting and challenging, because quite often our best regen farmers, their neighbours are farming in such a different way that we can't compare like-to-like rotations, and we can't compare like-to-like products. So it's very challenging, and some of our regen farmers are really just saying that how can you even begin to do that, because these systems are so different. So we're trying to work through some of these issues at the moment so that we can get to a place where we can determine exactly what needs to be identified for us to be able to determine whether carbon is actually functioning differently in these soils to how it is in traditional farming systems. So I'm just looking at the questions. Are any of those questions for me, or are we?
No, that's okay. There's a question about measuring aluminium in the subsurface.
Yep, okay. So I think that's probably a fairly good précis of where we're at the moment, unless anybody wants some elaboration.
Felicity, Lucas here.
Yep.
Yes.
I was just hoping that you might expand on your take or your thoughts around the carbon functionality in the systems. Because clearly, what we hear from regenerative farmers and in the media is that they're increasing carbon sequestration in their soils through whatever practices they're implementing, or the wide range of practices that they're implementing.
Yes.
What's your thoughts on the outcomes from that? Is it something that you've actually seen, and how are we going to look at what these functions actually mean for soil productivity and soil resilience?
Well, one of the fundamental principles there's a few regenerative systems are tailored specifically to the particular farm in each case, and so there's a range of different tools that they use, but fundamentally these farmers actually create their own means of integrating them in their own systems. But there are some things that are fairly common. One of them is about species diversity and about making sure that you are trying to get as much carbon into the lower level profiles of the soil through using mixtures of plantings with deep roots, shallow roots, and companion planting all the way along. And you can see we've got farmers like the Kelly family in the wheat belt who've got up to 12 different species in a paddock at one time. But the product that they're producing with that is quite different. They're producing an organic feed supplement for stock, and they're getting a $200 to $300 price premium for their product into that market. But it's a niche market. But you see, when you dig into his soils, you will see that the compaction that is common for that area has been quite dramatically changed, and you can see that that the multi-species cropping has the root systems going in such a way has clearly made a visual difference to what you're seeing in the soils. He's also, of course, incorporating the composts that we were hearing about earlier as well, and he's making his own teas, and he's doing all of that. And he also believes that it will put more carbon into the soils. This is very interesting because, of course, the types of soils that we see, particularly in the wheat belt, are these very sandy soils with soil organic carbon rates of less than 1%, sometimes down to 0.02%. So getting carbon into these soils is really challenging. And we had an interesting presentation at our recent conference, Talking Soil Health, from an expert at UWA, Professor Fran Hoyle, on soil carbon, and she was fundamentally saying that these sandy soils cannot be permanently, cannot have permanent stocks of carbon put back into them, that you are going to have to consistently work, and the moment you stop such a system, it will go from the soil. So am I answering your question, in that discussion, Lucas, or do you want me to go more into the sorts of testing that we're considering implementing on the sites?
No, look, I think that was good discussion there, but I guess one of the things that sort of popped into my mind when we're talking about the very sandy soils is, where there are farmers already starting to increase their clay content in their soil through delving and spading. Yep. Bringing up clays from depth, or finding a clay mine on their property and spreading that on the surface. Of course, one of the ways, one of the important mechanisms for increasing soil carbon content is through the organo-mineral protection of carbon. So you need clay, essentially, yes, to protect carbon in the microaggregates. So I'm wondering already, where there are practices, for example, of bringing clay up to the surface. Will that be useful in improving carbon content and the more stable long-term carbon content in those sandy soils as well?
Yes, well, certainly, clay is obviously, critical in being able to hold that. And of course, we have some areas where it is possible to bring it up from the surface, and that we are seeing some tremendous results from doing that from the subsoil, bringing and spading and mixing it in with the sandy soil at the top, and getting a much better result as a much better production as a result, and we believe better soil organic carbon content. But of course, most of these farmers have not had the opportunity to do the testing to find out what is actually happening. Yeah. They're using what they can see as the key indicators. So if they're seeing that the soil is changing through through the practices that they're using, and then they can see that survival rates are better, and that they can see that water holding capacity is better because you've got more growth happening than is happening next door on the same piece of land, on a geographically similar piece of land, but is being is still using synthetic products. Is that sort of evidence is actually there, and this is what this project is really trying to do, is trying to find out scientifically and to be able to demonstrate that it is making, that these practices do make a difference to the chemical, the physical and the biological functions of these soils.
Yeah. And yeah, that's an interesting point as well. Sorry, Felicity, for asking a couple of questions back to Felicity Gilbert here. But I think Felicity made a couple of interesting points there, around soil biology. And, there are not many labs do soil biology testing. And it's certainly not a standard routine analytical test, other than perhaps a predictor B, and that's more focused on disease. And also for organic carbon content, the majority of labs, by far and away the majority of labs, commercial labs, would just be analysing total carbon. And you have to ask specifically to break that down into inorganic or organic carbon, for example. And certainly, I don't think there are any commercial labs that start looking at carbon functions. So, it certainly exists in the research sphere. But as far as being farmers or their agronomists being able to test the different types of carbon components in soil, it's something that's very difficult to do. So hopefully, as a part of this project, Felicity, some of these farmers will actually have some proper information around what their practices have resulted in change around both total carbon content, but also the functions of the different carbons, and also maybe around some of the soil biological aspects as well.
Absolutely. Thank you, Lucas.
Yeah, thank you. Thank you, Lucas and Felicity. It's great to hear that there'll be some collecting of information from these farms. Because like you say, Felicity, there's lots of anecdotal evidence, but not necessarily much measured evidence. And Marnie's suggesting that maybe some of this collected data would be put towards a formal set of bioindicators, perhaps for biological health. But I think also, like Lucas was saying, there's a lot of work to be done in the laboratory field to determine sort of good and what are the beneficials and what do those beneficials do and those sort of things. So I really appreciate both of you giving us your time today, and I guess I would encourage you to have a look. There's still some comments being made in the chat, so maybe if you have a look at the chat, but I'm just conscious of time, so I'd really like to thank you both again. And yeah, guys, if you've got some more questions for Lucas and Felicity, please use the chat. But I'd like to introduce Gavin Beaver now, who's patiently been sitting online and listening to the presentations this afternoon. So thanks, Gavin. Gavin's with Extension Oz, which I think I showed all the participants the website at our first workshops. And Gavin's a relationship manager for Extension Oz, and he's just going to give us a brief introduction to Extension Oz as a platform that could possibly be used by our soil CRC communities of practice as it's being used by other communities of practice. So thank you, Gavin, and I'll hand it over to you.
Thanks very much, Felicity. Just noticing here as I switched across, I've had the same trouble as the previous speaker when I've gone across to the PowerPoint, so I will have to put it on the main screen. Just give me a quick sec. Is my screen sharing at all there, Felicity?
Not yet.
I'll give it a go now.
Yep, here it comes. Oh, it looks good.
All good?
Yeah, all good. Perfect.
Excellent. Okay. So no, I've really enjoyed the presentations today because actually in the late 80s, I started my career in soil as a SLIM extension officer and then moved into soil conservation extension, both in Victoria and then finishing up in Queensland, where we were for another 4 or 5 years. So it's a great project you're involved with and some really fascinating presentations today. But I guess today I'm not here to speak about soils as such, but more about the community practice approach. And so what Felicity and the Soil CRC have asked for is just for me to give a perspective on Extension Oz, which is a project, which is really an enabling platform that has been put together to assist communities of practice. And I know to look through the list of people, and that was probably through the crop nutrition and field crop diseases initial communities of practice that were led by GRDC. So really, as you all are experiencing, it's about the essence that communities of practice, it's about together we can achieve more. So often when people consider a community of practice, they look at outputs or what's happening in the community, when it is probably more about the relationships that form and build as you collaborate. And just looking at your chat box now, it's a good case in point as we see the questions come through and the interactions occur by you guys being engaged with each other. So Felicity, that screen's still working okay?
Yes, it's all working well.
Okay, so what I'll do just in closing for you today is really talk about the features of Extension Oz as an enabling service and also what the potential benefits could be to communities of practice as we go forward. So perhaps if I just think or get yourselves to reflect, what has been the greatest benefit of the internet for you? So essentially we're harnessing these different forms of technology, but the internet came around in 1994. So in the chat box, perhaps just share what some of the benefits of those, whack them in. because essentially what we're doing is we're taking some of those benefits and as communities of practice, using the online tools to collaborate remotely and share information and also be able to communicate together. So you all and your 3 different communities are in the business of sharing knowledge and information and skills. And a big component of that will be upskilling and assisting each other develop soil skills. And I guess Extension Oz is about trying to assist communities of practice do that effectively. So again, in the chat box, if you could just pop in some of your favourite online tools. So just jot a couple in, just what is your favourite online tool? So, you know, we all use different things. They're nearly in every facet of what we do. And so when we think about working as communities of practice, we're also harnessing how we communicate and the tools that we're familiar with, but also using our tools that we're familiar with, using those skills that we've got the capability to use others' tools. So your favourite online tools. And we'll come back to those shortly. So for those that aren't familiar with Extension Oz, and as I say, it's really not a noun, it's a verb, it's something that's here to help people. It's not a program in its own right as such, but it's based on a pilot that came about from Agriculture Victoria in 2012 with the Visiting Fellows program. And some of you probably saw Dan Cotton speak on those 2 occasions that he came across. And so they had developed a program in America, establishing communities of practice, much like yourselves, for particular purposes. And that was typically around subject areas to share and collaborate around content. And so they start with an information focus or whatever it is they might be trying to achieve. But it quickly became apparent to them that really what it was about, essentially if they were going to help people, was about the relationships that form and then supporting those relationships to do what they're trying to do. And Extension Oz in Australia over the last 6 or 7 years essentially has evolved into that space. So yes, we're really about helping you share skills, knowledge, information, but it's also about if we don't support relationships using different tools, then it's not going to work. So it's based on the approach that was piloted with GRDC, and the 2 communities were crop nutrition and field crop diseases. There's a whole story around those 2 communities, but they were very successful. And at the moment, there's 3 partners, Agriculture Victoria, New South Wales, DPI and AgriFutures. Now, AgriFutures is a managing partner, and what they do is they actually support the functionality of it. So they do the enabling service. And why it's a good fit for them is they support rural industries that don't have their RD&C functions. They do have a mandate for sort of the whole of agriculture to assist across Australia in the whole of agriculture. And they lead cross-sectoral research and innovation in Australia as well. So that's one of their mandates. So they're a nice fit for having an enabling service that others can use. Through AgriFutures, they provide my service, which is about the facilitation and assisting the communities of practice get the coordination role. They provide an IT manager who looks after all of the IT support. So for instance, if you were with Extension Oz today with your webinar, your online meeting, that IT manager could support you with the software, test it, get it going, etc., that sort of thing. And then they support a series of, or a team of developers that look after the platform and continuously improve it. Because today, I guess, you know, we do operate differently in how we communicate. And last question for you all, if you could just pop it in the chat box, is what communication do you use the most? So if I was going to upset your day 10 years ago, I could upset your filing cabinets perhaps. But now it's probably turn off your internet connection or mess up your mobile phone. So when you think about how you communicate now, what is the tool that you do rely on that you use the most amongst your colleagues and clients, your clientele? And just pop that in the chat box because we'll reflect on that at the end. Now, a bit of context for me. So we're on a property not too far from where Felicity used to live, I believe. So south of Bendigo. A son in quarantine, having come back from the US, studying psychology, one in year 12, mad keen farming, and Heather and I, who was also in the department, have been operating our business since 1998. And that little yellow dot at the top right-hand side there, 6 kilometres away, is an NBN tower, which is a blessing for us. And that enables us to operate differently. So from this location, I work with and support 14 communities of practice. Some of them will have synergies with yourselves, particular synergies. Well, nearly all of them will, but you know, ones like precision agriculture, the soil moisture one that's starting up now, the irrigating agriculture. So there are some synergies with what you guys are doing, and regardless of where it'll be good to network your 3 communities in with these other communities and the work that they're doing. And a bit of context then. So what does it deliver to those 14 communities? Essentially, they don't have to worry about the back end stuff. So, and they don't have to worry about the professional development in the skills and the tools. So the platform supports them, and then they can just focus on their communication and collaboration. So it's a fully supported platform. And by that, what we mean is it's sort of a turnkey solution. I'll show you the features, but you can essentially switch on any features and tools as you need them. And all the security, the storage, the backup, the archiving data, the communication tools are all sitting there. And also importantly, there's an exit procedure. So if you're ever to stop the communities of practice or any community of practice then under the relationship, the data is extracted and popped out to whatever format the owner of the community needs. As members, the communities are kept up to date with things that improve, and as new tools or initiatives come around, there's a training in those. I'm really going to, now this may sort of bombard you a bit, but it's really a suite approach. So if you're communicating and collaborating, like matching your needs as a community with the tools that are out there and how they communicate to best meet your needs without too much hassle in adopting them. So our communities to date have used websites, or their own websites and the ones that they create together to be the sort of the source of information. And then they link via different means. So social media, e-newsletters, nothing amazing in that or different. Using webinars and webinar platforms, YouTube channels. There's an Ask an Expert tool. And I guess the magic with that is that the triage system and how you can deal with people asking questions. Now, are they public? Are they private? Who are they sent to, etc. There's a widget that does that for the communities that want to have that functionality. Not all of them do. There are smart calendars there, and by smart calendar, what I mean there is that it's got features in it that you can switch on. So for instance, there's an example there from the Food Innovation Community Practice. You hover over it, it shows you what that's about. When you click on that, it goes to a post that gives the detail, and you can link that to quite a lot of detail. You could link it to a video, you could link it to a post or whatever you would like to do. There's podcasting available. There's a collaboration space, which is a Google suite of tools. So you can use those tools to share documents in a secure and private environment, again, backed up and supported by the Extension Oz platform. And there's online groups. So some of these are set up as private groups. So for instance, if you have communities that want to, as experts, collaborate and communicate quickly in real time, then you might have a private group. We typically use LinkedIn or Facebook groups, and or some of them are public facing, where the experts might like to go to the end users of the information, and some of that might be a group that you have to become a member of, or it may be a publicly facing group. So again, it comes back to the needs of the communities of practice. And there's different tools you can use, like, you know, if you're, say for instance, that's a bit of information that was posted on a site recently, It's got a ranking or rating service on it, so they can track the engagement with it. If it doesn't get much use, or the ratings go down or aren't high, then they can adjust that approach, what they're doing. And there's pop-up functionalities where you can, you're all familiar with pop-ups, to particular sources or particular people, as an example. A number of the communities now are going into augmented and virtual reality, using 360-degree cameras and things like that. And I guess that an example might be in the context of your subject areas. It might be, say, like a virtual soil pit, where you could take people on a tour of the soil pit. That conversation then about aluminium that was in the chat box, and there were conversations, pause and that type of thing, or the depth of the aluminium. You could show that in a in a virtual or an augmented reality fashion. And then it's linked to custom tools are behaving and track the analytics, and that's supported through Extension Oz. So if you think about how we operate, and even me dropping back into your world of soils, having not worked specifically in soils since probably the 90s, late 90s. So, we all pop up there as individuals, we run into each other, etc. When we formalise things, there is some forms of agreements needed. So Extension Oz, and through the experience in America, has an agreement templated process, which looks after all the legality and the IP, etc., which enables people just to network with confidence and, to move forward with whichever approaches they're doing. So just quickly in summary, I guess our experience is that as a community of practice, you're a team of people working in soils in 3 different locations. So you're going to where the people are in your location. You've got capability that's growing as individuals and in your organisations and in your audience. So it's how do we harness and make use of the smartphone, and it's amazing where it's come to today. Now, a key point of difference in operating as a community of practice is this curation. So maybe this is a little bit of an analogy for you, is if we can help you, or you yourselves get on top of things about how you function as a community of practice, then you really want to take these opportunities, and the funnel is the tools. So whatever approach you use. So once you've got a robust approach, and even today using Zoom, so each time you use it, it'll be easier and more predictable. Today's run sensationally, particularly for a first off, so that's been brilliant. But so it's just getting the funnel right, because at the end of the day, what we all want to do is provide timely, credible, peer-reviewed and trustworthy information amongst ourselves and to users. So it is that suite approach, and those, I guess, are what Extension Oz offers communities of practice. Extension Oz really isn't an entity in its own right, so it's really about, apple and pear integrated pest and disease management, one community. If you visited their site, you would think that you're on a Horde Innovation site, for instance. So it's not about trying to be an entity, it's about trying to support communities of practice with the things that they do need. Because there are things that pop up you don't realise, such as data management and archiving, such as IP, etc., that has been well thought through, and it's here to give people a hand with. It's good to note that it enhances but doesn't replace a community practice approach, and you yourselves will find that there's only so much you can do as you engage virtually, and as you look at how you're going to improve the skills out there in the different geographic locations and with different organisations. So it will still have to link in and complement and support traditional approaches. But in our experience, it's been tremendous seeing it evolve, the community practice approach. It's fabulous having now 14 communities of practice, because essentially what the approach is doing amongst that crowd is just sharing the knowledge and the information that comes about. So evolving together with a bit of focus. So in doing so, we can avoid some duplication as we learn to work as communities of practice. We can help improve functionality together. And it's really handy to have some help on call. You know, people you can go to for a tech thing or whatever it might be. And, you know, continues to build networks. Together we can achieve more. Analytics is pretty important, and how we use the different tools and tracking those as we go. So not rocket science, but it's handy to have that experience behind it. It is that process of continual improvement. And that's really the cycle that you're on now as 3 new communities of practice are relatively new. It will be about how do we continually improve our approach to achieving the focus that we have, where we're heading. What is coming that we keep an eye on, I suppose, is the Internet of Things. And, you know, some of you were actually in the room, I think, in 2013, when the cropping one was looked at in Melbourne. I think it was about 80 people in the room, and we asked people back then to put up your hands if anyone was on Twitter. And I think there was 2 people. So we just seen a rapid evolution in that period of time in the social media space and in online tools. But now what we're seeing now, that the paradigm shift, and you're probably already playing in the space, is that this convergence of digital and physical worlds is happening. So that's something that we need to keep abreast of and evolve towards. And there's, you know, good opportunities there. So Felicity, I'll pause there. I'll just turn off that slideshow.
Thanks, Gavin. That was a great introduction to the communities of practice, and I encourage the participants to go and have a look at each of those 14 or the ones that interest them. I also expect that the extension community of practice would be very relevant to all the participants, as that was an issue, well, not necessarily an issue, but a topic that the participants are interested in, because they're working to increase their own knowledge in managing soils, but then what extension tools and extension practices can they use to then get that information out to landholders and motivate and bring landholders along for the ride. So I think that, I know that extension platform is very useful and has lots of great information. Peter Clifton has asked, how do you start a community of practice? For example, first questions to group meeting for first time. Do you have any comments about that?
Yeah,
Gavin?
sure. So it's like what you yourselves have done already, is getting the right people in the room is the priority there. So having enough key people to have the conversations with. And you don't have, it doesn't have to be extensive, but it just has to be the right people. So once you have those people in the room, the first, and in your case, you'll already have some outcomes that you're trying to achieve. So it's really about that scope of work. So what is the scope about? And then the questions then really is what's already happening in the space? How are people communicating about it? And what are people directly involved with already? What ideas? So it's pulling the ideas out and that knowledge. Sort of perhaps an oral process is a good way. That tends to be the sort of approach that we use. So what is actually the focus of what the community is trying to achieve, and then the reflection. What's it about? What are people already doing? Because what you're trying to get to is some nice, easy first steps. Some action that you would like to take. That you as a group clearly say, geez, if we took this and this, just some low-hanging fruit, we're trying to get some first steps towards what you're trying to achieve. So we typically, and a couple of you have been involved in them, run a boot camp type process to assist with that.
Right. Okay. Thanks, Gavin.
We have some, actually, Peter, we have some little documents around that too, and some guides. There's actually a little checklisting for that first meeting and stuff. So if you guys would like access to that, be more than happy to provide them. Great.
That sounds great, Gavin. Thank you. I know that the regional agricultural land care facilitators have communities of practice as part of an output or an outcome. that across Australia. So I think each RAF needs to have 1 or 2 communities of practice in their CMA or NRM region. So they're quite interested in how to progress that and what that might look like. So Pete says thanks. Sounds great. Terrific. So I'm not sure, haven't seen any, did you want to talk about those questions?
Yes, so just going through the list there. So, and that's the type of things that you need to think about. So when you think back, say, 10 and 15 years ago, where we've come from, changing. So things like microfish, I see there, the old microfish, good comment there. So, but those sorts of tools, as we say, you have the experience that each individual has with tools that they're used to dealing with and work well. So that's one, I guess, low-hanging thing to do, is to look at these things that people are already familiar with and how they can help. So Sarah's put the Bureau of Meteorology site, fantastic site that it is there. And we do a lot of planning work as well, environmental and land management plans for different clients and things as well. And we use the Bureau of Meteorology site all the time. Slido, another great example. But there'll be some in here like, where are we? There was a couple, eSpade, Cal put in eSpade. So I'm not familiar with eSpade, I've heard about it. So there's, Cal's got something like that to offer to the group. So that's the example of working with that. So we need to reflect on how we're evolving, and then we can help others.
Yeah, great. Thanks very much, Gavin. I think I can see Heather in the background, can I? Is that,
did she walk behind me?
Is that
Probably did.
Heather?
Yeah, well, we had 2 Felicities. So Heather, they're wanting to see, boss lady, they'd like to see you. There you go. Yes.
I didn't have my video going. I was waving, but I forgot to turn my video on.
Okay.
Please say hi to her for me. Thank you very much, Gavin. We have gone over a little bit, so I do apologise to you and to the other participants. But I guess that is the indication of the interest from the group. So asking questions and engaging. So I do appreciate that, and appreciation to the communities of practice participants for hanging in for a good few hours this afternoon. It's not easy, it's a bit different sitting in front of a computer with headphones on compared to sitting in a room and being able to get feedback from people face to face. So thanks everyone, the groups, in regards to our next steps in the climate that we're in. We had a good Zoom meeting with the Southern group yesterday, so I'll be talking to the Northern and Western groups about perhaps progressing with another Zoom meeting for each of you. So if you, please let me know what has sparked your interest from today's quick grab with the program leaders and with Gavin. And if there's any more information that you'd like, please let me know. Gavin's popped in there the extension of site, so that's good. And Lucas is happy to take any questions offline. So please get in contact with those guys, and I encourage you to dial into the Soil CRC webinars that are going to be held over the coming weeks. So let me know if you didn't receive an invitation to that, and I'll get you on board with that. So thank you very much. And Catherine says, thanks, please contact her if you would like to as well. Thanks, Michael, for your feedback. It's been really good. And yes, if you've got any feedback for Michael as well. So I guess we'll sign off. A couple of us have got some other meetings to get to now, so I won't hold you up any longer. And please, yes, if you've got any feedback for me, please send it through. And I look forward to catching up with you all again soon, hopefully in person, but if not, online. And stay well, wash your hands, and don't sit too close. And we'll talk to you all soon. Thank you very much.
Thank you, Felicity. Well done.
Thanks, Gav.